that answer your question?
Final question. Dr. Sutter, can you compare the use of the throttle in a Boeing 777 with the use of cruise control in an automobile? How often would you expect an operator to monitor the speed when the machine always maintains the speed correctly?
Okay, so I guess you're trying to get at over-reliance and what some people might call complacency. I guess you could compare the use of a system like the autothrottle to a large number of different automated systems, and if an operator makes a large number of experiences with that system where the system operates reliably, then yes, we do see a tendency to rely on that system, which in a way is a sane response, if you will, to that experience. We also see that this actually changes quite a bit though over time, in that in the case of pilots, we have looked at how that reliance develops over time, and usually based on the way they're being trained and things are being explained to them, they may be over-relying for some time, but they make experiences with the system that calibrate their trust in the automation over time. And so usually with increasing experience, their trust in the system and their reliance on the system becomes more calibrated. I think one big difference I would point out, though, is, again, if you compare it to cruise control on a car, there's lots of differences in my mind. One of them is that there is not the plethora of systems that we have on a modern flight deck. So in other words, if I turn on my cruise control, there are not lots of other things that I have to monitor at the same time in terms of systems. At the same time, fortunately, in this case, or not, at the same time, you have a difference in terms of the operators. So a driver of an automobile will have a basic knowledge of what the cruise control does, but has not really been trained very thoroughly on that system. So I think there are some differences that need to be pointed out as well. But I think in general, we see when you provide automated assistance, and the assistance is fortunately highly reliable, then over time people might develop a certain reliance on that system.
Okay. Thanks, Madam
Thank you.
Chairman.
Thank you. Air Cruisers.
Madam Chairman, we have no questions. Thank you.
Thank you. Boeing.
Thank you, Madam Chairman. Mr. Myers, how does the Boeing flight deck design, as implemented in the 777, provide cues, enunciations, and other information to minimize confusion?
We design the flight deck to, per one of our top level philosophies, is that we design the systems to be error tolerant, and we apply automation to aid and not replace the pilot. But what that leads us to in terms of design is that we're looking for, in the area of, I'll just talk about error management. In the area of error management, we have to make some design assumptions about the pilots and about the automation and about the crew's monitoring skills. So if we ask a pilot to watch the paint dry, we don't expect to get the same level of monitoring engagement as we would if we asked them to, say, watch an Olympic speed skating event. We think they would be much more engaged in the latter. The same applies to the flight deck design. We expect that the cues we provide are available to the crew and that they will use those cues to the extent available. If they get behind the airplane or if there's an automation surprise, we expect them to back off on the level of automation as required and revert to more basic skills, either by flying just off the basic modes of the autopilot, for example, or going purely to manual flight. And we expect them ultimately, if the airplane is not doing what they expect it to do, that they can disconnect the automation altogether and fly manually. But regardless of what level of automation they're in, depending on the phase of flight, we'll expect the crews to monitor the fundamental course, path, and airspeed of the airplane. That's always what we expect them to go back to. And at the end, if they monitor those three things, and if they don't like the way the approach is going, they execute a go-around, then the intent of our design is made.
Thank you very much, Mr. Myers. We have no further questions.
Thank you. City and County of San Francisco.
Madam Chairperson, I'd just like to clarify that the spacing between the two runways at San Francisco is 750 feet apart, just for the record, and I have no further questions.
Thank you for that clarification. FAA.
Madam Chairman, FAA has no questions.
Thank you. Member Sumwalt.
Yes, Mr. Myers, we were just talking about monitoring. You were. And earlier this morning, you said, and I wrote down what you said, it's not an exact quote, but I believe you said, we assume our crews are very good at monitoring. And what data did you use to support that assumption?
We've used the data that we've gained in designing the systems and flying thousands of hours in the simulator and observing the pilots that we bring in from all over the world to fly the simulators. We're also getting the data from the flight tests that we fly. We fly thousands of hours of flight tests on all of our airplane programs, and we have engineering representatives on all those flights. We review the data, and from that, we found that response times for pilots are very low. They're good with critical phases of flight, and we can rely on them being engaged in those critical phases of flight.
Thank you. I realize the 777 was certified back there in the 90s, but are you aware of a study that Boeing's Randy Mumon, I think, Dr. Sartor, were you involved in that automation study? And I think that's what you were referring to earlier. It mentioned that flight crews, in fact, a lot of mode enunciations are missed. And Nadine, I think you said about 50% of the mode enunciations were found to be missed in that study. Is that correct?
So what I was saying was that about 50% of them across the board, and you need to differentiate a little because we were looking at, was this a mode transition that occurred as a result of directly preceding pilot input, or was it a mode transition that occurred with some delay because of some coupling or something of that sort? The numbers differ a little bit, but across the board, about 50% of the ones that occurred were fixated.
Thank you. So anyway, are you, Mr. Myers, are you familiar with that report?
Yes, I am.
Now, Dr. Abbott, I'd like to turn to you. You've been studying automation for a pretty good while. I'm going to suspect that the 96 report was actually commissioned at the end of 94, I believe, and then so you were involved in that, and then, of course, this one here that started in 06. And so over 17 years or so, plus prior to that, you've studied dozens of aircraft accidents involving automation, hundreds of incident reports, and literally thousands of reports from LOSA data involving normal operations. So what is your opinion of how well pilots are at monitoring highly reliable, highly automated systems?
I'll refer specifically to the data from the Flight Deck Automation Working Group report, and we looked at two categories. One was general monitoring, for which we did not have the LOSA data, so therefore we can't speak to the normal operations, at least from those data. But the accidents that we reviewed, approximately just under 40% of those accidents had a monitoring error of some kind involved in them. So those were the accidents that were reviewed by this group. A subcategory, it's not completely a subcategory, but cross-verification errors are related types of errors. And we saw in the LOSA data 25% of the flights had a cross-verification error of some kind.
That's very interesting. So about 40% of the accidents you looked at and 25% of the LOSA data you looked at involved a monitoring error of automation.
The first number, just under 40% was monitoring in general. The 25% of the LOSA errors were specifically cross-verification of inputs to automated systems.
I'm sorry, the very last part of that was?
Was specifically cross-verification of inputs to automated systems.
Thank you. Mr. Myers, is that consistent with your data for monitoring?
We don't have our data in that form, so I can't say that I have comparative data. But we do understand that there are errors in monitoring of things such as flight mode enunciations. But like I said, what we expect then is that if the crews are at all confused, that they have the capability to rapidly and easily exit the confusing mode and reduce to a level of automation that they're comfortable with.
Would you agree that in order to detect that they're confused, they have to monitor, and that's how they detect is through adequate monitoring?
Yeah, they have to monitor, but they don't necessarily have to monitor the modes. We hope they have the bandwidth. The workload is such that they're able to monitor all the modes, but if they are simply monitoring course, path, and airspeed, and if they don't like what they're seeing, they revert to lower levels of automation, including manual flight, then the problem can be solved, at least from a safety
Thanks. I'd like to ask that for the record you submit any data that Boeing may have used in the assumption that, like you said this morning, that we assume that pilots are very good at monitoring. Any data that you may have to support that, we'd like to have, please. Thank you.
Member Weiner.
I find the discussion about monitoring to be very interesting. There's really a couple of monitoring tasks going on in this particular situation. There's one task of monitoring another pilot, and then a lot of the discussion so far has been monitoring systems, and the point's been brought out that there's a hazard with automation that works right almost all the time, because you get surprised when it doesn't work properly. And I think I'll address this to Dr. Sartor. Could you just make a few comments about what you see as the difference between somebody performing a manual task and somebody monitoring that manual task?
You mean monitoring that task being performed by an automated system?
Well, in both cases, we're
okay.
monitoring another person doing that task and then monitoring that task being done by an automatic system.
So clearly, if you're in that way doing supervisory control, you have certain amounts of attention resources that are being freed up because you're not necessarily performing the task yourself. At the same time, that could actually create difficulties for you because you are not necessarily getting the same direct feedback, for example, that the person might get performing the task themselves. You probably also take a longer-term, higher-level perspective as you monitor as opposed to performing the task yourself. So I think your role changes and the resources you have available for monitoring changes significantly between the two of them. And I do not know whether you're referring in this case to the check airman versus the pilot. I assume that is what you're saying. The person in the right seat monitoring the pilot flying.
Yeah, I was looking at it in both cases, monitoring an automated system performing a task and then monitoring a human performing that task.
So if I compare those two, I think the big difference is, and that has, I think, been shown in several incidents and accidents to be a problem. If I'm a pilot and I monitor another pilot, I think I have a very good understanding of what I can expect from the other pilot because the pilot has gone through the same training more likely than not. The pilot will have the same idea of what our goals are, what our next steps are, how we're going to perform this task. So I think my view of the world and my expectations very much overlap with this other human being. And I have certain things I can rely on. So I know that they know certain regulations in aviation, for example. If I monitor an automated system, on the other hand, that system wasn't built by myself. It may have been built in ways that it performs tasks in ways that are different from myself. And so we've seen sometimes pilots monitor a system that worked perfectly reliably, but it worked in the way that the engineer had thought of the task. And so the pilot tries to monitor what the automation is doing and is in a way surprised because the automation does it differently from how they would have done it. So I think you're suddenly monitoring some agent, if I want to call it that hasn't gone through the same training, that hasn't necessarily been programmed to perform a task the same way. And I think that can make it more difficult to understand what the system is doing and what its next steps will be.
But if the automated system had been familiar to the point where the monitoring individual was familiar with what it was going to do, so then he or she would have a presumption of what the system was going to do. And is there then a parallel that the monitoring instructor has a presumption of what the monitored pilot is going to do?
Yes, so I assume if you assume that the pilot has the perfect, complete, accurate mental model of the system, then you could say, yes, he can make the same predictions, has the same expectations, and that's the monitoring strategy I mentioned earlier. It's really top-down monitoring is what's happening. It's driven by expectations. If the expectation is to be violated, then you would basically need what we call bottom-up monitoring, where some cue in your environment notifies you of the fact that what you're expecting may not be happening or something has been violated already. So now you need to be driven by data in your environment rather than by expectations that you have. But yes, if anybody ever had the perfect, complete, accurate mental model of the automation, then barring one thing, which is that you simply at some point may overwhelm the person with data in a short period of time. Outside of that situation, I would expect them to be able to predict just as well what the automation would do as they could predict what a human would do.
Very good. Thank you.
Member Rosekind.
So I'm going to start with Dr. Sartor and Dr. Abbott, but we're going to extend the same question to others. And the questions could be longer than your answers, because what I'd like really is a number and up to 3 on a list. There's been a lot of discussion about philosophy, and I think it's always interesting to see how much philosophy, data, et cetera, are actually reflected in manufacturing, the cockpit design, in the actual operations, in training. So I'm curious, starting with you two, how much do you think automation philosophy, human factors, design, et cetera, is actually reflected in the current state of cockpit design, training, operations? If you think it's 100% coupled, that's 100%. And then the second part of the question is, where are the gaps? I'm not asking for a reiteration of the report that just came out. This is one of those times you can give your own opinion and speculate, and you're okay. So just starting with the two of you from a scientific standpoint, where do you think we are as far as the penetration of everything we know, data, philosophy, et cetera, in actual status of what's going on now? And if you think there's a gap, identify like up to 3. Dr. Abbott, you want to start?
I can't give you a specific number. You've asked a very broad question across a variety of the airplanes that are out there and a variety of manufacturers and that sort of thing. I think there's been significant integration of the philosophies and policies of human-centered design into airplane flight decks. That has increased over the last 15 years. So we've seen significant improvements and a lot more attention to those topics. I think one of the important gaps that I would say sometimes does happen is a difference between the philosophy and the design and the way that the systems are actually operated. So I would leave it at that.
Great. Dr. Sartor?
I'm glad Kathy started that way, so I'm going to refuse to give a number as well, I think.
Well, if you want, I could put the pressure on a little more, because I'm not looking to the PhDs to say the data suggest. I'm trying to, that's the idea, is to look at this broadly across, the experience that you have and just get a feel. Are we, 90, 100% there, or, we're still in its infancy? We talk about this, but its actual reflection in operations training is really, where are we with that?
Well, I can tell you that we're at neither extreme, I think. That's a safe bet. I think some of the gaps that maybe I see, and I agree completely with what Kathy said, I think a lot of improvement has been made. I think it's also important to point out, given how everybody's kind of looking at everybody else, that everybody involved in this has the best of intentions. So everybody's trying to implement things the best way they can, given what we know. And to me, the last part of what I just said is maybe critical, given what we know. My impression is that There have been proposals, for example, for how training might be changed, how exploratory training may be more important to do in the way that a pilot in a simulator should have the opportunity to experience situations that they have never experienced before and sort of play in a supervised fashion with the system. That's a proposal that's out there, and I think maybe some airlines may have adopted some of it as well already. But then I turn around and say, what are the empirical data that we actually have to show that this will actually work? The same is true, I think, we talked about monitoring a lot. If we want to improve the way that pilots monitor, don't we first need data on how they monitor currently and to what extent that monitoring strategy is actually even associated with performance? Because right now we're often just looking at the process of monitoring, but we can't necessarily show that one way of monitoring leads to better or worse performance than another way. So to me, I guess being the scientist, I would say there's data missing. I think everybody is trying the best they can and they propose solutions to problems, but we don't run enough studies to show whether something is indeed effective or not.
Great. And Captain McKinney, I'm going to let you wrap this one. I just want to acknowledge a very thoughtful comment earlier, and so I'm kind of looking to you because you've had experience flying the airplane, being on these committees to sort of look at the design part of it and the training side. So, how much do you think all the stuff you've learned about has really penetrated these areas, and where would the gaps be?
Okay, I'll give you a number, or at least a guess, but no, I mean, it's just my personal opinion, but it's definitely greater than 50%, but it's probably, 70 or a little bit higher. But I mean, all the training programs, we're trying the hardest we can. We're doing what we know. I think there's a lot of research, I can tell you a lot of the gaps. So there's a lot of research that hasn't been done. I believe a lot of the training, from what I see, is a lot of the training is done as it was 30, 40 years ago. We got these new automated systems. We're trying to do it, but we're using old training techniques, old delivery systems. So we need methods of instruction. We need new devices to do the training. And we need new instructor training to teach the instructors, train the trainer how to actually teach this to the pilots. Because right now a lot of them are given the material, so we give them all this great material to do, but they don't know how to teach it. If that makes sense to you. So we train the successes. We train how the automated systems work well, but we don't train the exceptions. We're in the simulator a lot of times, and we do the pristine sim where we do it time over time, the exact same scenario, so the pilot understands it, they learn it, and then we check them on that, and they're good to go to the line. But what we didn't train them on, is what we didn't do, is we didn't give them all the different surprises that we've seen, or that shows from our safety data or our personal experience. We could do that very easily. An example, again, high and fast on final. I just went through training a couple of years ago, and I went out on my OE myself. And the first time that when I arrived, they gave me 180 to the marker because I had been off for a year, I hadn't flown, and they brought me in high and fast. I was like, I just realized, I just spent over a month in training. I never saw that once in training. And yet the first leg of my OE is there I am going, oh my gosh, and I was behind the aircraft because I was not prepared. And I was upset because I knew better, and I didn't understand that. So so the pristine world that we live in the simulator, we need to be training all the exceptions as much as we know. The other question is, how do we measure success? We need to really address that. And what I mean by that is, right now I see a lot of us training to exposure. We expose a pilot to something and we say they're trained. We assume that they understand it. But going back to what I just said, is if in that simulator I give them 2 or 3 scenarios that are realistic from what I would get on the line, and then I see if they really understood the knowledge and skills that I taught them, did they really get it? Because that's the only true test, not just show them once and assume that they got it. The assumption of skills. A lot of our training programs, and I've heard that word this morning several times, we assume that the pilot has skills, but how do we know they have them? And the key there would be that we evaluate that somehow. And so we have to figure out how we do that. And finally, with the difference in the automation policies is in our paper, in our study, there's a lot of confusion with automation policies and what we do. And the biggest thing I think that was an eye-opener for me when we went through the studies, we saw a couple of carriers doing it, is the separation of guidance and control when we're talking about automated systems. Some of the automated systems the pilots use for control, like such as the autopilot and the autothrottles. A lot of the other stuff is for guidance, but yet we group that all together in a linear fashion and usually say, hey, all the autopilot, all the automation off or all on. So we need to be training a whole different thing and then training our instructors. And one of the things that we said when we interviewed all the instructors, almost across the board, every group said that they wanted more training in how the automated systems worked and how to train those and actually evaluate them is what I'm talking about, how to evaluate those. And we need more research in that area. So does that help?
And I'm just going to, you've brought something up I've been trying to emphasize and would just be direct about it quickly, and that is you talked about successes. Because earlier, Mr. Boyd, one of your comments had to do with just because it meets the regulation compliance doesn't mean it's safe. And it's been one of the problems. We talk about hitting the standard and the criteria, doesn't mean it's effective. And that's what you're talking about in the operations, how much the data is translated, and in the training. And I think, we've got to get away from just compliance being different from whether or not your operation, training, et cetera, is actually effective for the outcome that you're seeking. And I'm not sure we always talk in those terms. Thank you.
Vice Chairman.
Thank you. I'd like to start with kudos to the industry for the series of automation reports they've done, for doing it on their own in a collaborative way and trying to tackle this challenge. And kudos for doing that, because I think that's very exciting. I'm going to ask a couple of questions that I don't know whether this report deals with it or are there any other reports, but I guess Dr. Abbott and Captain McKinney, does this latest report, or do any of you know of any studies that are granular enough to say this series of accidents and incidents had excellent CRM, and this series of accidents and incidents didn't have excellent CRM, and is there any intersection between good and bad CRM versus effective use of automation? Does that question make sense?
To answer the first part of the question, I would say no, that I don't know of any studies that really look at how CRM does compared to the accidents, what's good and what's bad. One of my jobs at IFALPA, CRM falls under my area of responsibility as the Human Factors Chairman for IFALPA. But what I can say is that, again, another one of the exceptions, or what we're not training, is we train CRM, and then we assume that the pilots can transfer that to their flight operations. And as an industry, I think we can make heavy strides in the safety industry. We figure out a way to integrate the CRM skills, decision-making, group coordination, communication, all those things while we're doing the maneuvers, while we're training them the operational maneuvers that they're going to be doing in a realistic environment. Because then we train them in the basic knowledge of the CRM. And a lot of us, again, a lot of the training programs cover it, but they don't cover it in depth. In the pilots, they expect that the pilots can make their transfer. And so if we can start figuring out a way to integrate that with the training, where we're not just training, for example, an ILS approach, but all those other factors with it, that's one of the keys. I think that's one of the areas that our reporting actually helped us find that we're missing.
I don't have anything to add to Captain McKinney's comments.
Thank you. Then a related question is, again, does either this study or any other studies that you know of, you're looking at how to make automation more effective, but do you go to the point where, oops, it was not quite effective, and so you have to do some sort of alerting? And the question is, are there any studies that look to the effectiveness of oral alerting versus visual alerting in bringing back that monitoring that was apparently absent enough to trigger the alert?
I'll speak to the update in the standards for flight crew alerting that have been recently instituted, and it wasn't a question of visual versus oral. One of the requirements in that new regulation, or rather the updated regulation 25.1322, is to have a dual sense, to have dual senses for an alert to assure the attention-getting aspects of it, so that you could have both visual and oral, or visual and tactile, for example, depending on the design itself.
And just to add to that, one of the biggest things I think out of our report for the Flight Deck Automation Working Group was that we looked across the system and looking for a system solution, not a point solution. And in my experience as an accident investigator in the safety world is that a lot of the solutions to many of the accidents and incidents is that they look at the point solution, they say, okay, we'll just fix this, and they don't see what the repercussions are. And a lot of people hear me, is that all you do sometimes is just move the workload, move the task. So you solve one problem, but you just move it somewhere else. And so my hope is that we look at this accident as across the system to find out what all this into a system solution, which is what our report was trying to do, so we can attack all those issues to make it a safer world. Thank you.
Thank you. And one more question is, you mentioned that this report has 18 recommendations. What's the prognosis who are these recommendations made to, and what's the prognosis that anything will happen on those recommendations? I assume some of them are regulatory recommendations to the FAA, but some of them are probably to various aspects of industry. What's your prognosis that anything will happen? What are the next steps to make sure anything happens?
The good news is that there's already a lot of work that's going on to start implementing those recommendations. So none of the recommendations require new rulemaking. Some of them do recommend new guidance material based on existing regulations. In addition, there are a couple of forums for allowing industry and FAA to work together on voluntary aspects of doing recommended practices and making improvements. The Commercial Aviation Safety Team is a great example of that. There are others as well.
Well, thank you, and again, kudos for taking on the challenge.
Dr. Abbott, you worked on both the 96 study and the study that was released this year. Can you give me a sense of whether we've seen a delta or a change between the manual versus reliance on automation when flying large transport category aircraft in those years?
That's a hard question to answer because back in the 96 report, we did not have the data available to provide a baseline. We had insights based on interviews and voluntary pilot reports. One of the things that we did identify in the report that just was released, the Flight Deck Automation Working Group report, is increasing use of the automated systems, especially to reflect the changes in airspace operations that involve more use of the flight management systems and so on.
And just in general, because we're talking about some of the challenges related to automation, but there are also some positive things with respect to automation. Do you believe that automation has made aviation safer?
Yes.
Okay. I am looking at the appendix on your study, and it actually has information about some LOSA observations, and it talks about the number of automation errors that occurred in different phases of flight, and actually one of the highest phases of flight where they have automation errors is descent, arrival, and landing, and there's a little bit more specificity when you talk about some of the poor marginal automation management ratings there, and in particular, it talks about vertical mode confusion, and vertical mode confusion, speed, energy issues, and our lateral vertical deviations were all coded against about 40% of consequential outcomes, and this is specific to descent, approach, and landing. And so I want to go back to something that Dr. Sartor raised earlier when Dr. Bramble asked her one of the first questions out of the box is what are the big challenges with automation, and mode confusion was one of the things that you referred to. And so let's talk about how we actually create better mode awareness. What are some of the specific steps that you would recommend be taken to understand the mode that they're in and not to be confused about what it might be able to do for them?
So I think we really have this two-step process going on. That's why I mentioned earlier, it's one thing to get them to notice the change, and then it's another one to actually get them to understand it. So I think the first task we have is to ensure that that their attention is indeed being grabbed by that transition. And I think that can happen various ways, and we talked just a few minutes ago about different various visual, auditory, and we might add tactile alerts to that. There was quite a bit of work on that during the 90s, basically. So that
maybe I can slow you down right there, because I know you understand all of these things, but maybe we're not all keeping up with the speed of your conversation, but maybe we also don't understand it. Yes. So when you talk about the improvements that can be made that are visual, or I'll explain specifically what you're talking about. Are you talking about things that the aircraft would do, like alerts that would come from the aircraft, or are you talking about call-outs that would come from the crew? So elaborate on that a bit.
So I was talking in this case about feedback that would come from the airplane that would be displayed on something like a PFD in the FMAs, for example. And the work that I was referring to was basically looking at what should the nature be of these indications, of these alerts to the fact that there was a mode transition. And there have been experiments looking at in what modality should it be presented. For example, currently we talked about the little green box earlier that stays there for 10 seconds. So a lot of the feedback is visual in nature, and when we look at modern flight decks, there is an awful lot of visual information being presented, so there is this risk of visual data overload. And so people have talked about maybe we should move that information to other channels. And I think that's in part where the call-out idea comes from, so it's an auditory thing, no longer a visual thing. It could be that you use the sense of touch. That's why I mentioned tactile information presentation, because we know that pilots tend to complain about visual overload on flight decks, but also already to an extent they complain about auditory clutter on flight decks. So there is an awful lot of auditory information presentation as well. And so that actually is what triggered the use of other sensory channels like the sense of touch. And we use that for some things like the stick shaker, for example, right? So that would be one step in the direction of trying to make sure that pilots, no matter what task they're engaged in, and most of them are visual in nature, that they are still capable of noticing that there was a transition. But then the next step would be to say, you may look at it, and as I mentioned from this other study earlier, a lot of them, in this case 9 out of 10, looked at the transition. We know that from eye tracking data, and yet they never said anything or did anything about it. And when asked about it later, it became clear that they saw it, but they didn't understand that that wasn't the mode they should be in or what that mode actually meant. So I think that's more a mental model issue, and the mental model part probably evolves through 2 different channels. One would be training, and that is the exploratory training I mentioned a moment ago, where I said, well, maybe if they had a chance to actively work with the system through exceptional cases like Dave McKenney was saying, that helps them build this model actively rather than just being taught a model. They build the model, and I think that could be more effective. And the other way, of course, is through line experience, where they actually experience these situations, and as a result of that, they update their model of how the automation works, which in turn helps them build expectations, which in turn helps them monitor. So I think the 2 really need to go hand in hand. It's the design and the training to get the observability and the mental model in place.
So I think it's like that old game of telephone or operator, where you have a situation where it starts with the designer, and what does the designer know? What do they understand about the system that they've created? And then it moves to the manufacturing process and the materials that the manufacturer might possess or prepare or provide to people about what the designers were expecting the aircraft to do. Then you've got potentially the operator and the materials that they may produce, which may be different or they may be the same. And then you've got trainers who may be separate from the operator. And then at the end, you've got the pilots. And so it's kind of a long path to get from the designer to the actual pilot who needs that information and understanding how that works. I think we've built that with panel 1 talking about the design and the certification, and panel 2 about some of the operations issues and the training issues. And here we're talking about some of what you're seeing with respect to line pilots and experience in the real world and some of the challenges. I do want to conclude with the issue with respect to the mode confusion or the mode awareness. Do we have any empirical data, research data that you can share with us, and you could provide this for the record later, that would tell us, again, what specific steps you want to take? I'm not a pilot. I don't know, but when I know that we've had a lot of concerns in the past about altitude deviations or kind of violations there. That's a significant issue. It's important. When I watch crews in the cockpit, I'm just in a jump seat. Again, I'm not a pilot, but I watch them. They get the information. They read it back. If there's a problem, they hear it. They talk about it. They dial it in. They point to it. They repeat it. I mean, there is a lot of communication about that. That's important. They don't want to get that wrong, and they have a good communication about it. When we have a situation where we have a pilot in command who doesn't really understand what mode they're in, not aware of what mode a crew might be in, and you have a crew member who doesn't even understand that, even though they may be involved in the cockpit, what mode they're in. That's a real issue of confusion. It's not just understanding what the mode does, but not even understanding if you're in a particular mode. That I think, how do we get to a point where, if we know mode confusion or mode awareness is an issue, how do we get to a point where we don't have that same kind of confusion? Because it's not just in this accident where we're raising this issue. It's over and over again.
Yes. Number one, yes, I'm more than happy to share everything that I can in terms of empirical data on this issue. And number two, I want to mention one thing. So we talk about the design, and we talk about the design of the flight mode enunciations, and then the training for monitoring them. I think one thing that has not been discussed very much, I briefly mentioned earlier that pilots in the study that we ran, they did not look at the flight mode enunciations very much, but what they did monitor more closely was the actual airplane behavior. And I think that is an important link as well. And I think there have certainly been efforts and successful efforts there in that arena. For example, in the 90s, one of the big issues everybody talked about was that pilots had a hard time understanding VNAV modes, vertical navigation modes. One of the problems, I think, at the time was that all they would have on the flight decks at the time was a top-down view of their flight path, but they did not have a side view of their flight path. So basically, they had the lateral information, but not the vertical information. And that triggered a lot of development and introduction to flight decks of vertical situation displays. So now, I do not just look at something and it says VNAV path or VNAV speed, and I, in my mind, have to figure out what that means for the flight path. But I have a side view of the actual airplane path, which shows me where am I going to go next, and what is the airplane going to do? Is it going to level off or not? So I think it's an old principle Don Norman used to say, put knowledge in the word, not in the head. And that's what that does. It puts the knowledge in the word on a display in front of the pilot. And for the pilot, that's data that they are used to dealing with. To look at a flight path, for example, rather than looking at VNAV speed and trying to figure out what might that mean. So I'm not saying we get rid of the VNAV speed, but I'm saying we also provide a visualization of what that implies.
Great, thanks. You've given us a lot to think about. Additional questions, Member Sumwalt?
Thanks. I'll make just a quick follow-up, but first, point of privilege. Dr. Abbott, I want to thank you and congratulate you for your efforts on this. I know you led the 96 report, co-chaired that one. You co-chaired, along with Captain McKinney, this recent report. These reports, both of them are in the docket under Section 14 if anybody wants them, but I know it was a group effort, but thank you for your leadership there. Dr. Abbott and to Dr. Sartor, I flew an Airbus A320 before coming to the board, and when I read that the accident captain, the trainee captain, left seat captain, had just come off of the A320. I wondered about this. As we know, the Airbus has the non-moving throttles, and I'll have to admit the first couple times you're flying the Airbus, it's very uncomfortable, thinking, oh my gosh, I can't really push the power up. It will come up, and then over time you develop confidence and you monitor your engine instruments just like your engine instruments pretty darn carefully to make sure they're doing what you want them to. What I'm wondering, and first, Dr. Abbott, does your data show anything where you may have had, and we know that the trainee captain in the accident said that he expected the autothrust to work. He said he thought the autopilot would, the autothrust would still work unless he manually disconnected it. He believed that the autothrottle would come out of idle to prevent it from going below minimum speed. That was the theory, at least, as he understood it. That's from his interview summaries. So do you have any data to show that maybe coming off of an airplane where autothrust is always engaged and you don't have to mess with it, any data to show that could lead to airspeed complacency or over-reliance on the autothrottles or anything like that? It's supposed to be a short question. My apologies, it turned into a long one, but hopefully a short answer.
We don't have data specifically on that circumstance. We did have data that showed, in some cases, over-reliance on the automated systems.
Over-reliance on
Over-reliance on the automated systems, and sometimes that was based on not a full understanding of the automated system behavior.
Thank you. Dr. Sartor?
No, if you ask me for data, I don't think I have that. I would like to point out, though, that you could actually add one more step to what you just described, which makes things difficult, and that is, imagine, for example, you have somebody who is first officer on an A320, then moves maybe up to first officer through various steps to a 777 or some other airplane that has back-driven throttles, and now say they move further up the chain to captain and start on a DC-9. I think there is an additional problem step there because you have somebody move back to an airplane that is much less automated to begin with. I think also that in a way, on both airplanes, whether or not the throttles move, you could say the auto thrust function is there and the pilot could start over-relying on it. But another issue could be, we talked earlier again about expectation-driven monitoring. So if I'm used to dealing with a throttle or a thrust lever that's in a detent position and never moves, and now I switch, do I even still expect that movement? So I think it is fantastic to have that movement and help me out, but does the pilot actually have the expectation of it anymore if he has flown or she has flown an airplane for, say, 2 years where the thrust lever never moved? So it's one thing, again, is what we provide, and it's another thing what the pilot does with that based on his or her expectations.
Thank you very much.
Member Rosekind.
Quick question, and either Dr. Abbott or Dr. Sartor. I'm curious, we're talking human performance and automated systems. So how extensive is the literature on other human factors like distraction, fatigue, time pressure, workload? When we start adding those things into this system, is there a big scientific literature on that, or what? Those other things that could affect?
There is a sizable literature, I think, on all of the topics you mentioned, distractions, interruption management, task management, all of that. It is not necessarily literature that reports on research that was conducted in the context of aviation automation. To me, that is not a big issue as long as we understand to what extent it generalizes or doesn't. So in those areas, there's a lot of literature, yes, but we need to carefully figure out to what extent we can use it in this context, I think.
Great, thank you.
Do the parties have any follow-up questions? Asiana? Okay. APU?
No more questions.
Okay. Boeing?
No questions for Boeing.
San Francisco?
No other questions, thank you.
Thank you. FAA?
No further questions.
Okay. Mr. LeBaron, it's back to you.
Captain Cox, we have time for one question from you.
Yes. I'll direct this to Dr. Abbott or Dr. Sartor, really. We have two controls on an airplane that are fundamental in every airplane, the control yoke and the throttle or thrust levers. Those are fundamental. It's one thing to overlook the position of an FMA or a presentation on a display or a button or a switch. It's another thing entirely to overlook a primary flight control. Can you think of, in your studies, any examples of accidents, incidents, or other events that you studied where the pilot simply overlooked completely for a period of time a primary flight control like a throttle?
So the short answer is no. I cannot give you a particular study on that. I do want to mention one thing that has been studied but not specifically to flight controls, and that is the issue of the ineffectiveness of queuing by absence. I think that's an important issue to think about in this context here as well, which is let's have two hypothetical cases. Let's have a pilot who expects that the throttle will not move, but the throttle moves. That is very likely to capture their attention. However, if the situation is the other way around and it's the absence of the movement that they should detect, that is usually something that is much less effective. So I think it's a general problem that has been studied in other contexts, but not to my knowledge specifically to the flight controls.
I have one more for Captain McKinney, if I could. Maybe I'm going to trump you here. Have you flown the A320?
Just in the simulator when I was.
Let me ask you personally, your experience, what's the difference in the tactile feedback in an A320 versus 777? And you can be general or specific and talk about not only the feel of it, but also the trim feel.
Are you talking between the stick and the yoke? Or what do you mean by the tactile feedback?
The controls you actually move to cause the airplane to change position.
Yeah, in the Airbus, I'd flown a couple of them in the simulators, but they all flew pretty much the same. That there's not a lot of tactile feedback, and I've flown a stick in the Air Force, so it's more or less it was just you set your pitch and the aircraft trimmed to that. Where in the 777, 747s, 67s, whatever, is that you do have the tactile feedback when you are moving it. It shows you that it's a heavy aircraft or not. That's what you're getting at.
Okay, thank you.
And I just want to, and to the previous question, I just want to add something, if I could, was, I forgot what it was when you asked me, but I'm trying to think what the question was that you asked before, because I apologize. But
well, examples of prior accidents where somebody just seemed to tune out one of the primary flight controls.
Oh, okay, yes, yeah. Something I think is important to point out, and is, as pilots, we have clean wings out there. We're developing very good airplanes. We're developing these approaches to get us in at the minimum fuel. And right now, with the coming in high and fast on approaches, the throttles are almost always at idle until the last minute. And it's one of my concerns I'd like to bring out, is because we have to look at what the unintended consequences of that are. So if I hit a certain altitude, whether it's final approach fix or whatever, but if the approach is designed for me to be at idle all the way to the final approach fix, and I rely on that automation, nothing happens for the last 15 minutes, and then it's supposed to come up. That's if nothing happens. But it's just an interesting thing that we've noticed in our report, in our data that we saw, is that there's a lot of that going on. So when we say, well, the throttles aren't spooled up, in the old days they were always spooled up, but now they're always in idle because I'm high and fast, and I'm coming in and just saving it at the last minute on most of my approaches around the country. And the other thing I'd like to say, too, if I could, is I think it's important, is, Madam Chairman, you hit it right on the head when the way you explained it, of the way the telephone call. That's exactly what our study found, and the same thing. And to answer your question real quickly on that, is we need to make the pilots proactive instead of reactive. And I think it goes to Mark Rosekind also, sir, is that we get a lot of our training in fixed-base simulators where we watch things happen. We watch the automated systems do that. We push the buttons, watch it happen. And over time, the pilots are watching it happen, and we're not being proactive anymore. That's why I'm saying we need to have a flight path management policy that makes us proactive, that we're using the system. So we have to turn our training around, so we're not teaching people to be reactive. We want to be teaching them to be proactive. And in the stalls and upset recovery that we've been working on the last 3 years, we're dealing with prevention, which also will help us here. So I think that's another area that we need to look at, is how do we prevent unstabilized approaches. So again, if we go back to 10,000 feet, 5,000 feet, we make the pilot proactive, that they're actually looking for all those threats and errors that they could accumulate, so they never get to the point, which is the way we did the training in the past. We actually expected them to get to the stall, to the unstabilized approach before they recovered. And if we, in the work that we did on those studies, is if we don't ever get there, then we don't have to worry about it. We still need to know how to recover from it, but if we can prevent it in the first place and start that missed approach at 1,000 feet, 2,000 feet, whatever it is, and say, you know what, this approach is over because we already know it's going downhill fast. And that's where I think as an industry we can help do a little bit, to answer your question. Thank you.
Thank you, Captain McKinney. We're going to shift gears a little bit after dinner, so I'd like to go through the IOUs up to this point. So just to reiterate again, we covered this one once, but Mr. Myers from Boeing, the formal process, the level of warnings, that was going to be Exhibit 2 X-ray. The second item is Mr. Kwang Hee Lee, the Korean Office of Civil Aviation, and that is the most current Korean flight safety regulations in English, and that will be Exhibit 2Y as in Yankee. Number 3, Captain Byung Kwon Yu from Asiana Airlines, confirm whether or not the training slide with the highlighted area was pre or post impact, and you can do that by just providing an email to me. Then fourth, Mr. Myers, data to support the statement that Boeing assumes pilots are good at monitoring. That will be Exhibit 2 as in 2Z, as in Zulu, and all of those are due by January 18th, 2014, and that's all I have.
Great. Thank you, Mr. LeBaron, and thank you all. I think, Dr. Sartor, you gave me a new term that I'm going to enjoy using a lot, disturbance management, and so thank all of you all for your willingness to work with us in our disturbance management of our process yesterday. And we will be back for a late night tonight. We're going to have a quick dinner. We will be back from dinner to start our panels 4 and 5 at 5:15.